Good afternoon, everyone. My name is Keith Hewlin. I'm the Director of Business Development here at Ascent Geomatic Solutions. We're excited today to talk with all of you about the benefits of UAV and LiDAR. And if you don't know what those terms mean, we'll explain that here in just a moment, for transportation and civil infrastructure projects. We'll go ahead and get started here, but I did want to let everybody know that if you have any questions, on the right-hand side, there's an orange arrow. If you want to hit that and then go ahead and select the questions there, you can type in your questions. And what we'll do is go ahead and go through the presentation, and then we'll look at those questions at the end. This is being recorded, so if you, for whatever reason, need to jump off and come back, we'll have this posted on our website before the end of the week. And with that, let's go ahead and get started. So again, today the topic is benefits of UAV and LiDAR for transportation and civil infrastructure projects. Now, this is really exciting because today I am joined by the esteemed, prestigious Owen McKee, who is our remote sensing manager. Owen, welcome.
Too nice, Keith. Too nice.
Yeah. So Owen leads all of our efforts here as it relates to remote sensing, which is drones and LiDAR and all of that neat type of technology. I am Keith Hewlin, again, the Director of Business Development here, and so what we'll do is just kind of share this presentation and go through a number of different examples with you, both from a UAV side and also from a LiDAR side. Here's essentially our agenda. We're going to just do a very quick overview on Ascent so you're aware of who we are, and then we'll go through a general overview of terms for UAV and LiDAR. Then we'll talk specifically about some of the different deliverables that you can receive both from UAV and from LiDAR, and then we'll go through some quick recommendations and open it up for questions. Does that sound all right by you, Owen?
Sounds about right.
All right, great. So by way of introduction here, if you're not familiar with Ascent, Ascent has actually been around for the last 12 years. We are previously known as our older name Petroleum Field Services. We've been in the Colorado Basin here for about 12 years. We started in 2006. We've got a little over 80 employees. Our headquarters is here in Denver, but we do have offices in Midland, Texas, and Williston, North Dakota. We primarily began working as an oil and gas firm, helping as a service company to oil and gas, mainly in land surveying, as well as then civil engineering and some regulatory and permitting, as well as some other services that are more specific to oil and gas. But over the last year and a half, we've moved into some other areas such as transportation, land development, landfills, and then just general civil infrastructure type projects. The main types of services that we provide is, again, land surveying, civil engineering, GIS services. We do work on the regulatory and permitting side, and then the purpose of today is really talking through the UAV and LiDAR services, not specifically that we offer, but more just in general about what you can actually do with that type of technology on projects today. So with that, let's go ahead and jump into just kind of a quick 101 on UAVs and LiDAR in general, for those of you that are not as familiar with the technology. When you look at these types of tools, it's really just the evolution of where this technology is going as it relates to land surveying. You know, if you see the guy on the left there, that is obviously using a transit or older type of technology, and nobody uses that anymore. As of about 20 years ago or so, the evolution then moved to GPS units as being kind of the norm. And as you know, every single surveyor is using GPS today. And you know, what's interesting about this is it wasn't as trusted as a technology maybe 20, 25 years ago, whereas today, obviously, it's very much the norm. And we just see this as the next evolution of technology in land surveying. You can see some examples there on the right-hand side with one of our UAVs, one of our terrestrial LiDAR units off the side of the road, and then even a mobile LiDAR unit on the top of, I guess that's actually your car, isn't it, Owen?
It is, yeah, that's my rig.
So we believe personally that in 3 to 5 years, this is really very much going to be the norm. We've just been lucky enough to be on the cutting edge of this, and I'll explain why that is here in just a moment. So we're going to be using some different types of terms, and so just by way of introducing everybody to these terms. We'll just do a quick 101 on UAV and LiDAR. UAV stands for unmanned aerial vehicles, aka drones. Unmanned aerial vehicles, or UAV, is obviously a more positive connotation than drones have been in the news. But we also are going to be talking about LiDAR, which is light detection and ranging. This is very similar to sonar or radar, where it's going to send out a pulse and it's going to get a return. There's different types of LiDAR. Terrestrial LiDAR, which we basically will mount on top of a tripod, and there's different ways in which we would use that. Mobile LiDAR, where we're collecting data at 45, 50 miles an hour. And then even aerial LiDAR, where we're actually using a UAV, or potentially even could be just a conventional plane. Multi-rotor, this is a type of UAV. That's what you see up there at the top, which is the yellow kind of UAV that's got multiple different arms coming off of it. That's better for flying a little bit lower, a little bit slower, and it's going to have a little higher resolution. It's really just a different type of tool that we use in the tool belt. And then we've also got the fixed wing down below in the bottom right, and that's more of your conventional airframe. So that's going to fly a little bit higher, a little bit faster, but it's much better for larger areas of land. So land development, it's great. Longer corridor projects, that's going to be very useful. You're just going to be able to collect data a lot faster and a lot more data on larger areas of land because it also has a longer flight time. Ultimately, what we're collecting from this is a point cloud. So it's just a set of data points in a 3D coordinate system. These are all defined by X, Y, Z coordinates to basically represent some sort of a surface. And we'll show you some examples of what some of those surface models actually look like. So in talking about FAA and kind of local regulations, I'll let our resident expert here, Owen is actually a FAA remote pilot, certified remote pilot, so I'll let him kind of talk to this slide.
Yeah, definitely. Thanks, Keith. Yeah, just like with everything in life, there are rules and regulations that we have to follow in order to be able to fly and use this technology legally and by the books, both at the federal and local levels. Up until about a year and a half ago, there was a 333 rule set that everyone had to follow, where you had to have an actual licensed pilot along with a visual observer. It made work a little difficult to get done. So the FAA kind of loosened things up a bit last year and developed the Part 107, which opened up the field for a lot more folks to be able to utilize this technology commercially. But that also made it kind of a more ripe ground for a lot of people that don't necessarily understand geospatial components and different elements beyond just how to fly. So it's been a good and a bad thing at the same time. There's certain rules that you have to follow under Part 107. You have to be within line of sight of the bird in the air, so you have to be able to see it at all times. We also have to stay below 400 feet in the air, so we cannot exceed that cap. And then you also have to make sure that you have airspace considerations, because there's certain airspace that you cannot fly within. There's certain airspace that you can fly within, but it's going to take waivers and authorizations that you have to do and account for time on. That's one of the kind of key factors in determining, can we use the technology for a certain area, and so we'll dive into more of what we do in those situations when we can't necessarily. And otherwise, we always have to take into account the local ordinances, because there's a lot of people that just don't want you flying, having a swarm of drones flying around in a city park. And so that's why a lot of cities and counties have regulations against people flying drones just in parks. And just like anything, you can always get a waiver for it if you explain that we're doing it for actual projects, and most cities are going to be aware of the public projects that are going on in the area.
Yeah, I think that makes sense too, right? Nobody wants to have hundreds and hundreds of drones, unregulated drones that are just flying in the air above them. So I think that makes sense. But we've run into this as a firm that provides these services, Owen. We've run into this numerous times, haven't we, where we had to get those permissions, and it's fairly easy, wouldn't you say?
Yeah, it's not bad at all. It's something, as long as you have a good reason to be flying and there's a good end product, and most of the time these guys just want to come out and watch you fly.
Yep.
So that's always kind of the fun part.
And make sure that they can see the new technology. That makes a lot of sense. So next, what we'll kind of go through here is high-level benefits of UAV and LiDAR. So when you look at what are the main benefits that you're really going to be able to get, There's really 4 of them. Looks like this is just taking a second here to switch slides, but I can go ahead and talk through some of these. The first one is just that it's much safer. So generally speaking, we're able to, as it relates to transportation projects, we're able to stay out of the roads, which is really key. That in talking with some of the state agencies like Colorado Department of Transportation, this is something that they like quite a bit because obviously safety is first and foremost for them, and it is for pretty much most companies. But this provides us a way, as you can see in the middle image there, that's one of our terrestrial LiDAR units that is capturing millions and millions of data points safely by the edge of the road there. Obviously we'd have a truck with lights and some cones set up, but that just gives you an idea. And then if we're flying over it, obviously, it just makes for a much safer area. Also in just certain areas that are just not safe to be able to get into. So floodplains and some of those different areas where it's just, or maybe a very steep kind of grade to it. There's just a whole bunch of different areas where it's much safer.
And when it's difficult to obtain permits too. So when you deal with railroads and right-of-ways like that you can't necessarily get within line of sight of the track, but you can collect it from the outside with lasers like we do.
Absolutely. Yep, that's a great point. And then more data. So ultimately here, we're able to collect a lot more data than conventional surveying. I do want to mention, obviously, that before I even move forward, that there's a conventional survey aspect to all of this. We are a conventional survey firm, so that's how we look at all these projects, is that we're performing a survey. But what we're able to do is just gather a tremendous amount of data that we never would be able to get, or nobody would want to pay for, I'll put it that way, if we were doing it conventionally. I mean, you're talking about collecting, 1,000 acres in a few hours. There's no way you'd be able to get topographic data on 1,000 acres in a few hours. And then less time, so less field time. This obviously helps with safety. The less time that you're on the actual site, the less the likelihood that something could occur, but also the less time that we're just going to be in the field. So there is a processing component to this, which it's not that it's just going to be 100 times faster, but overall, all the time. But we are going to be in the field less, and there is that processing time. But when you look at the overall scope of the project and how long it takes, the larger the project, I guess I'll put it this way, the larger the project, the more time you're going to save. Is that a safe statement to say?
I think that's a fair statement to say. I think scalability is key there. I think if you have large-scale, multi-mile project, the offset of the field time, is all of a sudden you start talking about weeks worth of time that you could be saving on large-scale projects compared to conventional methods.
And then last but not least is better deliverables. So, or maybe you could say enhanced deliverables here. I mean, really what we're talking about is the ability of seeing all this in a 3D environment. And, obviously we can still produce 2D deliverables, but we can also now provide 3D deliverables, which is really helpful for a number of different reasons, which we'll show here shortly. So as far as why UAVs and LiDAR, again, just some of the details here. We mentioned safety, less field time. I will mention less return trips to the field. That's obviously something we hear a lot, and we've experienced a lot as a conventional survey firm, is being called out to the same job site multiple different times. But this helps eliminate, maybe not 100%, but at least it eliminates quite a bit, because we're able to gather more data. Instead of having to go back out to collect more topo because something changed on the project, we can just pull it up on our computer screens and make the business decisions with the clients. Limited lane or road closures. Obviously for transportation projects, this is a big one. When we're flying over or collecting the data from the side, we don't need to be closing down roads. There's an expense to closing down roads, as everybody knows, and just limiting that just for the public convenience factor is obviously something that's very attractive. On-time deliverables, obviously deliverables that can be provided in MicroStation, InRoads, AutoCAD, ArcGIS, shapefiles, you name it, all the same types of formats that you're familiar with. Enhanced project planning and better project efficiency. So do I have empirical data to tell you that UAVs and LiDAR are going to automatically make your project 30% more efficient, and you're going to save 50% on your cost. I don't have that empirical data because every project is different, as everybody knows. The scope, the deliverables, they're always going to be different. But what I can tell you, and I think everybody would agree to, is if you're not going back out to the same location multiple times to collect data, and you're getting it all on the front end, if you are providing a more safe way in which you're collecting that data, and if you're ultimately using more enhanced deliverables to make better business decisions based off of more data, that's going to enhance the project efficiencies.
Yeah, and also just for general thought there, it reduces the impact on the public too. So if we're using lasers or UAVs, we can get information behind fences, on people's property without actually having to go on there. So we don't have to go and impact and have to deal with that public outreach component necessarily to get that topographic information that we normally would have to do. That slows things down a lot and creates a lot of potential headaches for projects.
Yep, that's a great point. And last but not least here, I'll just mention the engaging marketing. So we have worked with some clients actually that are using this now on the front end in order to win bids. So having us go out and collect data on the front end, overlaying their design plans. We actually have an example of that here that we'll show you in a little bit. So because I have our resident expert here, our local surveyor, Owen actually was a surveyor for the city of Aurora for a number of years and also led some of our survey teams here at Ascent over the years. So he is a very skilled surveyor. So I'll let him kind of talk to this slide.
Oh man, just talk me up, Keith. So the idea is that a conventional survey, you're going to be getting a kind of a grid pattern. You're going to hit key grade breaks. You're going to get primary features because in the end you have a budget. You have a certain amount of time to get a certain level of detail. So we will always go out and get what's required at a minimum in order to be able to reach a certain contour input or a certain frequency. So the advantage of using UAVs and LiDAR is that you create that point cloud that Keith was talking about. And within that same space where you may only get a handful of points conventionally, you're getting hundreds, if not thousands of points that will show you every little undulation in the earth. And so we don't necessarily use every single point, but the idea is that we can get a much more densified and much better depiction of the earth. So when it comes to your volumes and your quantities that you're dealing with, especially on large scale projects, you can start to really see cost savings and benefits because moving earth is expensive. It's a big process, and if you mess up those calculations, even over the course of just a few inches, over the course of many square miles, it equals big bucks. So that's where we really encourage this type of data collection to have that much better of a product to look at as far as the accuracy goes.
Yeah, and I think this lends to the project efficiencies, right? I mean, now we're not guessing in between what these lines say, 50 by 50 grid here, having 4 points and having to guess what's in between those. It takes the guessing game out of it. We know now exactly what's between the 50 by 50 square foot.
Yeah, and you get into levels of details like what does the roadway surface and condition actually look like that you could never capture with conventional.
Correct. Yep. So Owen, maybe you could talk a little bit about 2D and 3D.
Yeah, so once again, kind of like you were talking about with the deliverables, in the end, we always work back to what do you actually need out of us in the end. So when we or any other provider goes out with LiDAR or UAVs to get these large, robust point clouds, you don't necessarily need or want a point cloud delivered to you. You want the data and intelligence from the point cloud extracted out and put into normal, tangible products that, MicroStation, AutoCAD, GIS, that people can actually use in all the different agencies and the folks involved. So just kind of on the left as an example, there's I'll say an orthomosaic that we actually collected, and then the standard, in this case it's a DOT project, so we were using inroads, and it's all your normal levels within MicroStation that you'd want. We'll extract that out, deliver a field look, deliver whatever product it is, and then in the end, on the back end, we have sort of the right side example of the really robust three-dimensional environment that we can go and extract more from it, more is needed after the fact. So we extract out what's needed at the parameters of the project per it was scoped, and then we have additional information available for when someone all of a sudden says, hey, let's expand it a few hundred feet more in one direction.
Yeah, I think that's helpful for folks, obviously, because not everybody is going to be familiar with using these types of deliverables up front, but it's kind of you're able to crawl before you walk and kind of walk before you run, and that's where you can just take them on as you feel more comfortable, start using some of these other deliverables. As far as applications, there are a ton of applications that UAVs and LiDAR would be good for on civil infrastructure and transportation projects. These are just a few that Owen and I came up with. So I'll just run through these very quickly. So highway corridor projects, using, when you're trying to get design grade data on 15 or 20 miles, there's really just no substitute for using something like mobile LiDAR, or depending on the tolerances you're looking for, maybe getting some using photogrammetry. Municipal and county roadways, same type of idea. ADA intersection compliance, this is a huge one across the whole country, and we actually are working with a few firms right now on the ADA intersection, being able to scan the entire intersection so that you're not just collecting conventional corners of the intersection. In less time, we can actually get the entire intersection and get thousands of times more detail, and actually you can get more data that you don't even need specific for maybe that particular project as far as replacing a ramp, but maybe getting other information like what types of lights are they? Are they LED or are they something else? So
yeah, absolutely. And then there's even we have programs that automate what the slope is of the actual ramps that exist. Are they in compliance or are they not? So not only it's to do the replacements, but it's also to do the identification. Running mobile LiDAR, running systems like this, you can really start to identify and key in on those areas that need work to be done.
Sure. Yeah, it's just, again, the same idea we've been talking about, collecting more data. And then just general location planning and design. I guess in that I would mention the land development, being able to collect large areas of land, lots of data, lots of detail for planning purposes. If a new housing development is going to be going in place, or maybe a new commercial project is going in place. As well as, and I'll jump to the bottom here just real quickly since we're talking about this, as-built. Being able to know that what you design is actually what's being built, and actually overlaying the designs on top of the as-built and getting that to within very, very accurate types of tolerances. That's extremely important, especially when you're in an area like Denver where there's all kinds of development going up, and being off just a few inches or a foot or so, that's going to really affect you.
Big consequences.
Yep. Video inspections and monitoring, we have some examples of that that we can show, but obviously this could be used for bridges, it could be used for stability analysis, it could be used for just understanding what does that particular show. I want to see visually what does this intersection actually do at peak times during the day, during rush hour.
Yeah, traffic counts.
Traffic counts, exactly. We have a great partner that we work with where we're actually helping them with some of this right at this very moment, looking at what those traffic counts are and monitoring. Because obviously you can have a traffic count, and that's great because that's really important to have. But visually being able to tie that with the traffic counts is very valuable.
Yeah, you're talking about, as far as the applications go, again, they're unlimited, but you go from the traffic counts, which is when you're doing the feasibility studies, to flying and collecting for design, to going through, we do construction work, and then going all the way to the back end where you do those as-built, you see how everything was built. You can use these tools during the entire process of figuring out and implementing and completing a project.
Yep, that's right. So last couple things here that we'll mention are volumetrics. Obviously that's an easy one. That's a no-brainer with UAVs. To get, as opposed to having somebody climbing up with a rod on these huge stockpiles, that doesn't make sense today when you can easily just have a drone go up there, collect the data in a tenth of the time, and you're collecting it probably to within better accuracies than just going up there and crawling up that thing. And then mapping railroad crossings, and also water resource mapping. So floodplains, what else?
Just general drainage. Where does the water go? Does it go onto the road? Does it go into into a ditch? Does it, where does it actually go? And just understanding how the hydrology affects given projects. You just get that large scale view of where is water going.
Sure. After the floods of 2013, you know, being able to quickly identify exactly what happened, that's something that drones provide a huge advantage to, is instead of having to, you know, go work with a conventional plane, which is generally going to be more expensive, you may not be able to get as much data as quickly as you would be if you were just able to send up a drone that day and gather a lot of that data. All right, so now we'll kind of get into some of these deliverables. Deliverables, again, I want to reiterate, we're talking about 2D and 3D. So as far as generating DGNs, DWG shape files, right-of-way exhibits and easements, all of this data being able to integrate into GIS and CAD platforms, the answer is yes. All the standard packages that folks are used to getting, you still get those same types of packages. It's just these other deliverables like orthomosaics, 3D PDFs, fly-throughs, viewers that we'll show examples of here. It's all of those additional deliverables that really are adding a benefit to these projects, because it's being able to look at the area with a different lens now, and can ultimately help you make better business decisions. So let's talk about actual UAV deliverables. We're looking at 3D meshes. Tell me about 3D meshes, Owen.
Yeah, 3D meshes is basically a smoothed out, colorized point cloud that represent the surface that was collected from the air here. And we have a few different examples here. There's some where it creates a really smooth surface. There's some where we can add in model features. This begins a lot of that visual component. What does it look like to a layman? What does it look like to someone that doesn't necessarily have CAD to get in front of and look at and analyze? This is what anyone can hop in and see what the actual environment looks like that the project's being planned or worked in.
And then orthomosaics.
Yeah, so I mean, again, if we're collecting photogrammetry, we go and we can compile these orthotips, these orthomosaics of the you know, project area, and from that, once again, the idea is this isn't just photos. We're tying it down with ground control. We're getting check shots on the ground. Like you said, we're still doing a fair amount of groundwork to get that done, but we can actually develop full DTMs and surface models from that. So those pictures that create this great orthomosaic also become the topography and the development for the contours that you need to put into your electronic files.
Yeah, so we're really, you know, obviously a lot of the folks that are probably listening on this webinar right now, they use Google Earth as a starting point, right? I mean, we're very familiar with that. Google Earth, obviously, depending on where you are, could be 3 months, it could be 3 years or more old. And so planning new land development, planning new buildings, planning highways, any of the planning that you would have using Google Earth, you know, there's a risk there, because obviously you don't know exactly what's on the ground at that particular moment. So what these orthomosaics are gathering, if I just summarize what you just said, is two things. One is up-to-date aerial imagery. So now we know exactly what's on the ground. We don't have to guess, because Google Earth might be 2 years old. And we're gathering data off of that. So now we have topographic information, maybe potentially cultural information, but other types of data that would be important to us on the project.
Absolutely.
Is that right? Okay. And then up-to-date aerial imagery.
Yeah, just photos. I mean, it's amazing. If we're out there at the front end, we're setting some control, you want to see what a project area looks like ahead of time. You know, we have certified commercial pilots on staff that these are small little drones. We can just send them up and get some photos, just start the scoping and scouting concept, or we can do it as actual progress reports too. What does it look like just as a photo snapshot? Since we're out there already construction staking or doing the design work, let's just send a bird up. We can take a few photos. It's amazing what people can get out of that intelligence.
Sure, or environment, health, and safety. So just looking at what the job site actually looks like and getting a very quick view. I mean, having a bird's eye view just gives a whole different perspective. You can look at an image and in, you know, basically milliseconds, you can determine exactly what's happening, as opposed to just getting a report written out in email, right?
Yeah, exactly. And then I think this next slide here even just ties in further to that. We kind of mentioned video monitoring before. Again, get out at peak rush hour, get out at different times during the day, see what the volumes are doing, see what the traffic patterns are doing. Where are those choke points, you know, when you drop from a 4-lane to a 3-lane, how does that affect and how far out? By just having some simple video of a given space, like this as an example, you can learn a lot from it, and you can also develop that into your true traffic counts for, again, your actual front-end development.
Yeah, as we're showing some of these videos too, just to let everybody know on the call that these may come through a little bit, I don't know, spotty or a little bit jagged, just because it's going through the internet. These are very large files, some of these, so it's very smooth on our end, but it may kind of be a little bit broken up on your end as you're watching it. But we do have a lot of these on our YouTube channel if you want to go visit some of those and kind of see them in the real time. So we talked about this a little bit earlier. We see this all the time. There's some sort of planning effort, whether it be in the transportation space or the infrastructure space or land development, whatever it might be. This is that example we talked about earlier, where you can look and see what Google Earth provided on that particular day, and on that exact same day, you can see what up-to-date aerial imagery shows on the right side. And what's interesting about this is that this was actually in a residential area. You know, generally Google Earth is going to be more updated the closer it is to a major metropolitan area, which this was. So as you get further out, you get more of a longer
kind of perspective, just understanding what has the change occurred, what does that mean, and again, how does it impact your project?
Yeah, the legacy of the data basically. So it's a much longer period of time as you start to get outwards into remote areas. It could be 3, 4, 5 years old, and so it's funny even just looking at this example where this is in a major metropolitan area and still, you know, not as updated. So if you are planning on this particular area, you'd want to know that there's homes there and roads there.
Yeah, and again, I think even the next coming slide ties right into what you're just saying. It's once we or a provider goes out on the front end and you establish that control and you've been out on a site, to be able to repeat and come back and get that progress of, again, that legacy concept. What did it look like over time? We're able to go out, and this example here is just a little land development project we've been involved in, that we've gone out periodically at key milestones, key pours, that you can start to see how does it actually look. And once again, because we're tying down the ground control, it's a real survey, we're able to go and lay in the actual plan and design work and see how is it coming together. You know, how did they develop the drainage? How did they put in the foundation? Did everything actually match per spec? And it gets ahead of any potential large impact changes immediately. So if you can do these on a weekly, monthly, just key milestone basis, you can start to get ahead of issues before they get too far down the line. You have too much on the ground that is going to be impacted.
And just to clarify what we were looking at there, those were point clouds. So that was not just a drone flying around gathering aerial video. That was actual data that we were looking at.
Yep.
So this next piece, I actually had a conversation with somebody that worked for an engineering firm, and they were talking about, you know, is there any uses for UAVs and or LiDAR for more geotechnical type of work? So, Owen, I know you worked on this project. Maybe you could talk just quickly about what's happening here.
Yeah, definitely. This was a project we did where we were contracted out. They needed to figure out what they need to scrape off, where they need to put bolts in to help prevent any rock slide along the highway zone. So we're able to take this, and with either photogrammetry or LiDAR, we can go and we can get enough detail that you can actually start to create these discrete fracture networks out of the detail that we're acquiring. You can identify, you know, your dip and strike and everything that you need for a geotechnical analysis to figure out where are your actual failure zones to better plan out your bolt patterns. And once again, this is another item that if you're dealing with volumes and quantities and you're trying to figure out how do we develop and mitigate a zone like this, the amount of rock and the amount of material you may have to move, again, becomes money. So how do you better plan at the front end, even before the project starts? You know, give it a scan, give it a flight, get an idea of what's going on to better understand what you're going to have to do to mitigate this type of a process.
Okay, great. So stockpile volumetrics, this is the one we talked about earlier, which is kind of a no-brainer. It's just a much safer way, and you're able to collect more accurate type of data in a much faster time than doing this conventionally.
Yeah, and we've done it with LiDAR and we've done it with photogrammetry, and truthfully, photogrammetry, the amount of detail, because you're getting it from above, you're preventing shadows from developing, so your accuracy you're getting, like you're saying, compared to a guy crawling around on the ground or even scanning it from the ground, you get great detail from the air on this. So we've seen excellent results that are incredibly accurate off that.
Well, we've mentioned accuracies here a couple times, Owen. Maybe this is a good time to just take a quick pause and kind of talk about what types of accuracies should we be seeing, both from a photogrammetric side and also from more of a LiDAR perspective.
Yeah, absolutely. I mean, you know, once again, with anything in life, there's relative and absolute accuracies, and we can say LiDAR, we can develop true absolute accuracies on down to, you know, pure survey grade, call it 0.05 of a foot, less, depends on, once again, how tight the control survey is. It's all, you know, whether you're flying it with photogrammetry or you're doing LiDAR, as your control is what guides the entire project. So that's where, no matter what, we're still surveyors on the ground really defining that out, because that creates your good quality. So LiDAR is incredibly accurate. You can get an absolute accuracy. When it comes to photogrammetry, you can get really good, you can get absolutes and you can get good relative accuracies down to probably, you know, we'll see entire project areas over square miles of land where we'll be at about 0.3 of a foot plus or minus vertically, and then again horizontally we're right on because we're using ground control. So it's at survey grade two-dimensionally. So all of our planimetric features that we can draw in and extract are going to be right at survey grade.
Okay, great. Let's talk about mapping cross sections.
Yeah, absolutely. I mean, again, this is another example of something that traditionally has been done by a guy on the ground with a GPS and a rod, and, you know, going and walking transects, and you take key cuts across the kind of the floodplain there to put together a map and develop out the HECRIS models and figure out what does the floodway look like and how does it impact in certain rise events. And once again, you can do this much easier in a localized environment at a much less costly scale than large-scale airborne LiDAR with localized UAV projects. You can go and you can get just a handful of miles at a time, and you just get an immense amount more detail to better understand really how that hydrology flows and moves throughout a given corridor.
Okay. So this next video that we're looking here is more of kind of a as-built point cloud. So this is obviously a commercial building where, in this case, the idea of wanting to look at maybe replacing the parking lot or maybe doing some regrading and just kind of seeing, you know, what shape it's in. Obviously, you can see some pretty good detail with just exactly what the parking lot looks like.
Yeah, absolutely. Yeah, this one, again, this is a photometric mesh. You can see just the detail. You can see all the cracks and lines and all the patch that they've had to put in. So once again, they're looking to replace the parking lot. So how do they understand what it's going to take and the type of space they're looking at and come up with their new design? We were able to do that, again, just send the bird up, look at it, see what it does, get a really good feel for where it's at. And then in a second here, you'll actually see it turn into a LiDAR point cloud, which is where you start to get the true detail of what does the curving gutter look like, literally what is the design survey that you need to get that project accomplished. So it's using a couple different tools to get a much greater perspective on how do we plan this out better, how do we get better detail, and again, for a very reasonable cost compared to a guy going out and hand topoing an entire parking lot where you're never going to get all those subtle undulations that you would from this type of data set.
Well, and this is a great example, I think, of being able to have a combined approach where this would be something where it would probably have a little bit of conventional, well, obviously some conventional type of method involved, as well as UAV and photogrammetric and a point cloud coming from LiDAR. So we can take all three of those and essentially put those together, right?
Yep. Yeah. We would just, as we've said, the deliverables, we would extract out the line work and develop the contours from it and give the client a drawing file that they can use to plan out a new, you know, kind of a replacement.
Great. And so in this example, this could be land development. It could be looking at kind of floodways, but this also could be used for, you know, if you imagine this 10 years, 20 years ago before all these houses were even there, right? Understanding what the surface actually looked like when you were looking to put this development in.
Yeah, absolutely. And then I think if I remember in this example specifically, the roadway actually acts as the drainage funnel into the catch basins there. So the roadway is directly being impacted in events by large rain, and it's, you know, is it actually shedding it correctly? How's the, you know, condition of the road impact the way the water moves? Is it going, you know, as the road subsided and it's going into people's houses and yards now? You start to look at these global perspectives of what does a whole area look like. not just specifically what can I shoot with a GPS rocket.
Right. And so, so this is an example then of more of a specific floodplain or kind of drainage corridor. Again, this is, as you can just see, this is a point cloud here, like we've been showing and talking about. And so this is a combined approach as well, right? Using photogrammetric as well as LiDAR data and looking at these different culverts and as well as just the surface as well.
Yeah, absolutely. And in this instance, they were looking to actually redevelop the crossing. So they were going to redo the roadways in this project based upon the data we collected. So we gave them the all-over feel for the actual floodplain via the photogrammetry that you can see we're flying through now, and then got that really design-level detail that you can see right here at the bridges and the culverts. So that way they can do the real design and understand what's the flow rate through there, what type of a structure, what type of a replacement do we have to put in there to better understand. And with this, you can actually get levels of detail that I think we'll dive into in a second here that you just couldn't get with conventional methods.
Yeah, and so, you know, this is more of an example where we're actually demonstrating line work as opposed to even just what we've been looking at, which kind of looks just like the imagery, even though we know it's data. But tell me about a little bit more about the line work here.
Yeah, exactly. I mean, this is a DOT project that we've worked on that, again, the point clouds are great, but really what do you need? It's those contours, it's the curving gutter, it's the line work. That's what you actually need out of it. So when people ask us, what do I get? That was just a sort of visualization of the line work that you're going to get in a fieldbook file, in a DGN, a DWG, whatever type of platform you're using.
Great. And then this as an example, we actually talked about this earlier when we talked about marketing and the fact that some organizations now, some of the engineering firms are using this as a part of their bid when they get shortlisted to come in and show this is what their designs are actually going to look like, which I think everybody probably would agree that. So here you can actually see what that surface looks like now, and then obviously overlaying the designs and saying this is what it will look like. I think, you know, a picture says 1,000 words, a video says 1,000,000. You know, being able to walk in with a stack of plans, which is what everybody's going to do, of course, is great. But then being able to walk in with a stack of plans and a visual example of exactly how you can kind of see it when it's actually done, all said and done, I think that, and we know this to be true, it actually helps win some of these bids.
Yeah, people are starting to call it a visioning package. It's what can you put together to create a better vision for what a project can do. So now let's talk a little bit about LiDAR deliverables. Obviously, there's a lot of different applications, but you know, one of these being, you know, we're going to have clients that, and you know this and I know this, there are some folks out there that they are used to dealing with this type of data. You know, they've been working with LiDAR data for maybe years, and so handing them a raw point cloud, something that they would prefer, and that's very easy to do, right? Then there's going to be the other side of that spectrum, which is going to be folks that basically say, I don't have a clue what to do with this data. I don't want a bunch of data. I just want a deliverable that's going to help me make my decision. So maybe you could just talk briefly about the raw point cloud and some of the modeling. Yeah, I mean, the nice thing about the raw point cloud is there's programs we use that you can run through, especially on, let's think about highway projects where you're trying to figure out what are bridge heights. So again, you might not care about anything else within that point cloud, but the height of the bridge, where's that deck at, where's the lowest point at the beam, you can just automate through, and we can pick out those heights that way they can understand what are the heights as you go through. You can see examples kind of on the upper right and left here, where you also get to see where the height of masts, where the length of arms. There's small things that you can do that just provide a lot more intelligence because it's a difficult thing to capture conventionally on the ground. And then the lower left there, you can actually see some examples of some modeled-in features within an intersection that we can use to then, you know, manipulate, add in, change, alter, rotate, anything that we want as far as a design goes to get a better grasp on what will it look like and what will it become.
Great. So, you know, in an example of looking at something like crossings, you know, being able to scan this and essentially get the profile of these culverts, what advantages are there to using LiDAR scanning as opposed to just collecting this data conventionally?
Yeah, I mean, definitely in this example specifically, if you look at these culverts, these crossings here, you know that there's going to be sediment in there. So one thing that never really gets accounted for in a conventional survey is going to be the sediment itself. So how does that affect the friction and the way that the water moves? We can see that in there, and especially in areas that have had flood events and major events come through, where there's a lot of sediment, a lot of buildup. Really, what's the flow look like now? You can get that detail because you can get low enough in there with, let's say, a static scanner to look in and see what is it doing underneath the bridge.
And then if we have, and what we'll do is just very quickly see if we can jump out here and take a look at another byproduct when you do scan some of these, which is, well, let's see if we have an example here. Yeah, so looking at more of the 3D type of modeling. So as I kind of go through this, maybe you could talk through just a little bit about what you're able to do with some of the different modeling here.
Yeah, definitely. And as he zooms in, you can see this is what you can start to deal with your hydraulic models. How does the water move underneath this roadway, or at what point does it go over the surface, and does it breach the surface? Having this level of detail, especially with complex structures like this one, where you have these curved diversion structures, that type of detail with the height and just that information in big events has a major impact on the way it affects the roadway and the travel of the public. So by having this detailed information that we can collect using these methods and then developing into these nice, easy, tangible 3D PDFs, you get to see the line work, you get to see what it's really doing out there. So it's just a really nice, again, easy product that anyone can kind of open up and use as a discussion point.
Great. Okay, so let's jump back into the presentation here. So as we talk about corridor type of work, which is what we're looking at here, you actually were on this one, looking at things like sag lines and utilities, things like that. What are the benefits here of using mobile LiDAR?
Yeah, so I mean, mobile LiDAR is great when it comes to existing corridors. In this case, it's an existing transmission corridor that we're helping put in and look at a water line. So a lot of times your utilities are going to be put in next to utilities or within the same corridors and right-of-ways. So again, a lot of times, take a highway, for example, you're going to try and set that high-pressure gas line, along the corridor there. You can collect this information, get the entire level of detail without having to directly impact flow of traffic or having to deal with the high-powered lines. Or in this instance, this was actually a progress report during construction. We didn't have to get in the way of the heavy equipment. You can actually see right here, there's like our walking with a LiDAR backpack. So literally, we didn't have to walk within the actual corridor itself, and we got all of this information that just lets you see where's the nearest building, what's that sag wire, like you were saying. There's just an immense amount of information you can pick up for corridor work when you know that you're going to be dropping additional utilities in.
And then supplemented with just some very quick imagery so that, or video here, so that people can see not only the data but also be able to see, what it visually looks like. We're talking about mobile LiDAR, and there's multiple kinds. You can, I think that's one of the advantages with mobile LiDAR is that you can obviously use it for different types of methods of collecting data. You can put it on a truck, you can put it on an ATV, you can put it on a backpack, which was the example we just looked at there. And there it's all just kind of using a different type of a tool for a different type of project, right?
Yeah, it's all really versatile, and this type of equipment are all very high resolution scanners that we're using within those, so you can get design level detail out of it. You can also, a lot of people are trying to use LiDAR within UAVs as well. It's generally not going to be quite as accurate, so if you're looking at a large scale area, more of a generalized surface model, it's great for that, but when it comes to getting that kind of curb and gutter detail, the systems aren't quite there yet, so that's kind of something that a lot of people ask for, whenever we're talking to them about this. So it's something that we can do, and it's something that a lot of people do. It's just that it comes down to what do you need out of it, what's the level of detail, and that determines that tool.
Okay. Great. Well, before we get into just a couple recommendations that we would have for folks that want to start experiencing or using UAVs and LiDAR, let's just talk about one other byproduct here, which is a viewer. So we know this by collecting this data. One of the things that we utilize here internally is a viewer for our clients, where we don't need to send them a 300 gigabyte file that's going to crash their CAD system, right? We can actually have a viewer here, which allows for them to really be in kind of a first-person view of exactly what the job site looks like. But what they're really looking at is data here, right? And those two examples up above are LiDAR point clouds. What you see below is a colorized LiDAR point cloud. So I'll jump out here real quickly and we can take a look at this. And Owen, if you just kind of want to talk about, how this is helpful.
Yeah, definitely. I mean, this is essentially like having Google Street View at your project location. So you can go in, you can see here's the scatter of the point cloud. You can click on the station, and you literally are going to be the head of the scanner when we're using our static scanners. Like for an intersection is a great example here, where you can get just a level of detail. You can look up and see, is it a halogen, an LED light? You can do general inventory with it, so you can see what type of cabinets are out there, what's the condition of the markings, and again, like Keith said, this is something that anyone can just log in. It's a real colorized point cloud, so they can click measurements and they can annotate measurements, so they can say, look at this stripe here, it's worn out, it's X amount of feet wide. There's just a lot of information you can gain from this tool without having any software or any programs needed aside from direct access.
And we can actually measure based off, because this is just a point cloud with imagery overlaid on top, we can pull measurements on any of these. Anything that we can see here, we can essentially pull measurements on and look at how many inches or how many feet is something, or how many meters or whatever here, right?
Yeah, exactly. So just a really nice, easy byproduct of the tools we're using, and just what more can you get by having, a surveyor or someone on the ground collecting data with these tools.
Okay, great. Well, let's go through a couple of last recommendations here for folks that, again, might be considering using UAVs. We've been doing this for a while, and we've heard a lot of stories. Some of them are not as positive as others. So with this collection here, maybe we could just talk through these real quick. I think, number one, survey firm first. With Part 107 coming out, there was a lot of firms that entered the drone space. And I think, like you mentioned earlier, that's a good thing and a bad thing, because yes, it's great that there's now more applications and more, it's becoming more readily available, but in the same respect, there's a lot of folks that are having to try to learn surveying, which is much easier to be able to learn some of the technology. And because ultimately what we're talking about here is not just taking pictures and getting video, we're talking about an aerial or mobile survey, right?
Yep, exactly.
And then full service collection, processing, and delivery. So this is another issue that we've seen sometimes, where a firm is contracted, but they'll use their UAV or their drone to collect some of the data on the front end, but don't have the infrastructure or the expertise internal to be able to actually process all that data. So that gets shipped somewhere else. And ultimately, maybe there's a survey firm that's brought in to help set ground control. And before you know it, you've got 3 or 4 different folks involved. That can just delay the project. And ultimately, you don't have one firm that you can go back to and say, this is what I needed to make my decision on. This is what I needed as a deliverable to help make that decision. And where is it? And unfortunately, you don't have that if it's not a full service provider. The processing, Owen, obviously this is a big component, right? I mean, the amount of investment. There's a lot of folks that we talk to. Obviously, we've had a good chuckle sometimes, because it seems like it's an easier game to get into. Oh, we'll just go buy a drone and we'll take it up and fly and get a free software and we should be able to process it all. But as we know, when we're looking at this type of data, it's not that easy, right? There's a large investment into the infrastructure. The systems and the processing that you need to be able to process this amount of data is enormous, as well as having the people that can look at the data and then extract out what is actually needed on that. Anything else you'd want to add on the processing?
No, I think you hit it. I think it takes the horsepower of the computers to be able to do it, understanding how much time is it going to take, and that ultimately will impact how your timeline and what your delivery schedule is going to look like. So again, having that in-house and understanding the capabilities and the power that's needed to get there will really help you understand how well can you stay on track or hopefully ahead of schedule.
Yeah, and I think that's a great point, and a couple other things here. SOPs, so standard operating procedures, as well as safety measures. As we know, there is regulations out there that you have to abide by. If you don't, and you're flying commercially, you could be flying illegally, meaning that you are collecting data illegally on a project, which isn't going to reflect good on that firm. It's certainly not going to reflect good on the firm that they're collecting that data for. So, having those standard operating procedures to know we need to identify local airports and things like that is extremely important. If you don't know all the rules, then you could be breaking them.
Yeah, absolutely. I mean, process and procedure is key to any operation, and it's how you ensure safety, it's how you ensure correct execution, and it's how you ensure that you're going to get what's actually needed. It's a communication process internally and externally as well.
And one item that's not on here is I would just throw out as a consultative approach. And I know that is a cliche term nowadays, but it's in this respect it's very important because collecting data is a fairly easy thing to do. I say that there obviously are some nuances to it, but being able to understand what a client is actually trying to do on their project and what decisions they're trying to make is a much harder thing to be able to do. So I think just having that true consultative approach of understanding what the client's trying to do is extremely important. That's something I know here at Ascent we take very seriously. And then last but not least, of course, as a recommendation, always use Ascent Geomatics. So with that, let's take it to our questions here. I know, so as I mentioned, if you have questions, you can submit them in the orange arrow. That should allow for you to go to the questions tab there and just submit your questions. Looks like we've had a few that have come in over the last hour or so. So let's go ahead and go through some of these. Okay, first question here. Restrictions or limitations of using UAV and LiDAR. So I guess that's kind of referring to, in what, is there any cases, I'm guessing, where you wouldn't want to use UAVs or LiDAR?
Yeah, absolutely. Yeah, there's certain times where you're going to be flying over, crowds of people, potentially, like here in Colorado, CDOT has restricted airspace over their highways, over their right-of-ways. So there's certain areas that you really have to figure out what's the right tool and can I do this? And so if we have areas that we can't fly or there's airspace we're too close to a major airport, you know what? Probably using a UAV isn't the right tool. Let's think about mobile LiDAR. Let's think about what would it take to get guys to do it conventionally on the ground. We look at what you need to get done, and we figure out what the right tool is that we can legally and feasibly and also economically use to get it done.
Well, and I think this also lends to a recommendation we just had, right? Of if you have a survey firm first, then obviously if circumstances occur where you're not able to use the remote sensing technology, having that backup where you have traditional conventional methods to collect data is really important in those scenarios.
Yeah, because no one likes telling a client that, I'm sorry, we cannot use a drone for this project. People get very excited about it, but we have projects that we have to say, no, it's not the right tool. So you have to approach it in a different manner, and there's definitely organizations I know out there that do breach the rules and they do go against it. And again, like you spoke about, it causes some contentions and it could cause some real headaches down the line for the project.
Yep. Okay, well, let's look what else here. We've got another question. How much does this cost versus conventional? It looks great, but sounds expensive. Okay, well, so this is obviously a very fair question, and this comes up a lot. I would say I can take this one first. When it comes to cost, we always tell clients that it shouldn't cost any more than what you're already spending today to gather that same amount of information. In many cases, it's certainly going to be less in the overall project. I mean that because, A, if we don't have to go back out to a location 3 or 4 or 5 times to collect data, that obviously, as anybody would recognize, would make that a little bit less expensive than if we just have to go out once. But also, if you're looking at collecting very, very detailed data, you know, curb and gutter information on 25 miles, to do that conventionally versus being able to drive at 45 miles an hour and collect that in, you know, a couple hours, there's really no comparison there.
Yeah,
would you agree?
Yeah, I mean, and even what do you not get out of a standard collection method? You know, if we're using LiDAR, you get that pavement surface condition that is just literally impossible to capture with the GPS. So there's certain items that you just literally don't even get, and with fly-throughs and all the different kind of, you know, multimedia that we've been showing, you get all of that in addition to the exact same piece of data that you would get and pay for normally.
Okay. Looks like we just have time for a couple more here. Sounds faster to collect data, but what about overall time for deliverables? Owen, you want to take that one?
Yeah. I mean, basically, like we were saying, it's really on scalability. If you have 1 linear mile, you know, maybe it's actually faster to collect it conventionally. If you're dealing with 15, 20 miles worth of corridor, all of a sudden, that's a lot of time on the ground that guys are going to have to spend getting really fine, detailed shots. That's something where all of a sudden we can collect it, again, like Keith said, collect that in a single day. Yeah, it might be a couple of weeks worth of processing time, but all over, maybe your project actually winds up being on the deliverable 1 to 2 weeks ahead of time because we save so much time on the field end. And that ties right back into everything we talked about with safety and less time on the ground and just that level of exposure that we would have otherwise.
So there's definitely a scale factor plays in here, right? So if you're looking at a project that's a 1 mile long corridor, you know, time to collect probably isn't going to be any faster. Maybe potentially on the sides it could even be a little bit slower, maybe, potentially.
Could be, yeah.
But as that project expands, obviously then using remote sensing is definitely going to be more of a time saver overall.
Yeah, and you can think about, I mentioned railroad crossings, not having to deal with the flagging crews. You have to coordinate that stuff weeks ahead of time, and it's extra expense. And what type of right-of-way permits do you have to get, or permission to enters? A lot of that stuff you can kind of bypass and get around by having these remotely sensed data sets.
Sure, traffic control, you know, closing down lanes, all of that, and then obviously that all leads back into safety too. Yep. Okay, just time for one other question here. By the way, if there's any other questions, feel free to email me. My email address is here, as well as our phone number. So if you have additional questions, please feel free to ask those to that email address. Last question: how do you deliver these large files to your clients? Yeah, well, I'll let you take that one again. Owen, you're used to delivering these are large files, and we hear all the time that, you know, with folks that are not familiar with how to use this data, clients have said we either have too much data or, you know, or we have some file that crashes our CAD system. So.
Yeah, exactly. And like Keith was saying earlier, a lot of people aren't going to be getting a direct large point cloud delivery. Most of the time, we're going to extract out the features, the line work, the contours, and deliver a standard package product that you would need. We can also, if we're collecting imagery, we tile out the imagery so it becomes a lot more sizable and you can move around within your CAD platforms. But in the end, we utilize you know, cloud storage and FTPs and what we can deliver off large sets of data if that's what the client needs with no problem, and that's just an easy download. So there's different ways of going about it. It just depends on what do you actually need out of it, or do we store the heavy amounts of data and then keep extracting more information as it comes up.
Okay. Well, great. Well, I want to thank everybody for joining us. We're out of time. I also want to thank Owen, our resident expert here, for sharing knowledge. If you'd ever like for us to come out and actually talk with your group specifically about your projects and how this type of technology could help, then please email or call us at the number provided there in the bottom left. And with that, thanks again, Owen.
Hey, thanks, Keith.
And thank all of you. And like I said, this will be recorded and on the website. Thanks again. Everybody have a great day. This now concludes the webinar.